Hey, before you fall asleep, I want you to imagine something strange.
It starts with just one ant, then two, then 20, then 100, circling a single hole in the ground, around and around, faster and faster, as if something underground is calling them. To us, it looks like panic, or chaos, or maybe even a warning. But to the ants, this is nothing unusual at all. Somewhere in that spinning ring of tiny bodies is one of the strangest, smartest, and occasionally most tragic behaviors in the entire natural world. And by the end of tonight's video, you'll know exactly what's happening every single time you see it. Because it turns out there isn't just one reason ants circle a hole. There are four. And each one tells us something remarkable about how a creature with almost no brain at all can build a civilization more coordinated than most of ours. So get comfortable, dim the lights if you haven't already, and let's go down into the world beneath our feet. Let's start with the strangest version of this, the one scientists actually call the death spiral, or more formally, an ant mill. Imagine a single ant. It has almost no ability to reason, plan, or remember a map. It cannot see a hole from across a garden and think, yes, home. Instead, it relies almost entirely on scent. As an ant walks, it lays down an invisible trail, a chemical signature called a pheromone, brushed from a gland near the tip of its abdomen onto the ground behind it. Any ant that crosses this trail later can follow it, the same way you might follow a trail of breadcrumbs, except the breadcrumbs are made of smell, and they fade slowly over time. This system is honestly brilliant. It lets a colony with no leader, no map, and no communication beyond scent coordinate the movement of thousands, sometimes millions of individuals, all finding their way back to the same tiny hole in the ground. But brilliant systems can fail in strange ways. Picture a foraging party of army ants, a species that is functionally blind and depends completely on this scent trail to navigate. If that column is separated from the main group, something unusual can happen. An ant near the back may begin, by accident, to follow the trail of the ant just ahead of it. That ant follows the one ahead of it, and so on, until the very last ant in the line ends up following the very first one. The loop closes, and now every single ant in that circle is walking in the freshest, strongest smelling trail imaginable, a trail made entirely of themselves. Because the pheromone trail is reinforced every time it's walked, the circle doesn't fade away. It gets stronger. More ants join. The scent becomes so overwhelming that it's now the most correct path any ant could possibly follow. And so they walk and walk, sometimes for hours. In the most extreme recorded cases, entire mills, hundreds of feet wide, have rotated for more than a day, the ants only stopping when their bodies simply give out from exhaustion. It sounds bleak, and biologically, it is. But it's also one of the clearest windows we have into something scientists call emergent behavior, where no single ant is doing anything wrong. Each one is following a perfectly sensible rule: follow the strongest trail. And yet, out of thousands of individually sensible decisions, the group produces an outcome that serves no one. It's the same underlying mathematics that shows up in stock market crashes, in traffic jams that appear for no reason at all, in rumors that spiral without any single person lying. Simple rules repeated by many individuals can build something no individual ever intended. There is, by the way, a strangely simple cure. Researchers have found that if you interrupt the circle, even with something as small as a twig dragged through the ring, you break the chemical trail. The ants at that gap suddenly have no scent to follow. They pause, they wander, and within moments, the perfect, deadly circle can unravel completely, sending the survivors back out to search for a real trail home. So the next time you see ants circling a hole in tight, frantic loops, that ring you're watching may be the ghost of a broken shortcut, a scent trail that folded in on itself and became inescapable, simply because it worked too well. To really appreciate what's happening around that hole, it helps to understand just how sophisticated this chemical language actually is. Ants don't have just one pheromone. Some species use over a dozen different scent signals, each meaning something different. There's a trail pheromone for food this way, an alarm pheromone that spreads instantly when a nest is disturbed, warning nearby workers within seconds. There's even a pheromone released by a dying or dead ant, a chemical marker that tells the living workers, quite simply, carry this one away. In fact, scientists once ran a famous experiment where they painted that same I am dead chemical onto a perfectly healthy living ant. The other workers picked it up, still moving, still struggling, and carried it out of the nest anyway, because the chemical instruction overruled everything the ant's own body was telling the colony. It's a strange reminder that an ant colony doesn't really think the way a single animal does. No one ant is in charge. There is no general issuing orders from inside the hole. Instead, the entire colony behaves like a single distributed mind, built from thousands of tiny decision makers, each one reacting only to the chemical world immediately around them, immediately below them. Scientists have a word for this kind of coordination: stigmergy. A system where individuals don't talk to each other directly at all. Instead, they leave marks in the environment, and those marks guide the next individual's behavior. The trail is the message. The hole is the destination. And the whole colony reads the message written into the ground itself. It's the same basic principle, incredibly, that lets slime molds, organisms with no brain whatsoever, solve mazes, and even recreate efficient train network layouts when food is placed at the locations of major cities. It's the same principle behind a flock of starlings twisting through the sky as one shape, or a school of fish flowing around a shark like water around a stone. No leader, no plan, just thousands of simple reactions, adding up to something that looks, from a distance, like intelligence. And that's exactly why a circle of ants around a hole can look so purposeful, so eerily coordinated, because in a very real sense, it is. It's just not any one ant's purpose. It's the colony's.
But the death spiral isn't the only reason ants gather and circle around a hole. There's a second reason, and this one has nothing to do with getting lost. This one is about beginnings, not endings. Deep inside most ant nests, hidden among the ordinary wingless workers, live a very different kind of ant. Winged ants, called alates. Among them are the colony's virgin queens, sometimes called princesses, and the males, whose entire purpose for their brief lives is to help create the next generation. For most of the year, these winged ants stay below ground, waiting. They need very specific conditions: warm air, high humidity, and very little wind. And when those conditions finally align, often after a stretch of dry, hot weather, followed by a bit of summer rain, something remarkable happens across an entire region at once. Nests everywhere begin to open. Workers widen the entrance hole. Winged ants gather at the opening, restless, clustering right at the threshold of their home, waiting for exactly the right moment. And then, seemingly all at once, sometimes across an entire city on the very same afternoon, they launch into the sky. Entomologists call it the nuptial flight, though most people simply call it Flying Ant Day.
The scale of it is honestly staggering. These swarms can be so dense that weather radar systems have mistaken them for rain clouds. Birds, especially gulls, gather from miles around for what amounts to an all-you-can-eat buffet, because for one single afternoon, the sky is suddenly full of food. Up in the air, the newly winged queens fly as high and as fast as they can, with males in pursuit, and mating happens mid-flight. It's a brutal filter by design. Only the strongest, fastest flyers get to pass on their genes. Once it's done, the male's job in life is essentially complete, and most die within a day or two. The queens, meanwhile, do something almost unbelievable. They land and quite literally chew off their own wings they will genuinely never need again, and begin searching the ground for the perfect small crevice or patch of soil to dig into. If she succeeds, she will spend the rest of her life underground, sometimes living 20, even nearly 30 years, laying every single egg that will ever become a member of her new colony. So if you've ever walked past a hole in the pavement or the lawn and seen ants swirling and clustering tightly around the opening, wings catching the light, movement almost frantic with anticipation, you may not have been watching a colony in distress at all. You may have been watching the opening moments of an entirely new civilization, about to take its only flight.
There's a third reason ants gather around a hole, and this one might be the most quietly impressive of all, because it suggests these tiny creatures can do something we usually associate with meteorologists: predict the weather. Long before the first raindrop ever touches the ground, an ant colony can already be changing its behavior. Workers that were out foraging suddenly turn back toward the nest. Others begin hauling soil, pebbles, tiny twigs, and bits of debris up from deep inside the tunnels, packing them tightly around the entrance hole. In some species, the ants go even further, physically pressing their own bodies together, head to head, to form a living plug that seals the opening completely, at least for a little while. Why the urgency? Because underground, water is not a minor inconvenience. It is one of the single greatest threats an ant colony ever faces. A flash flood can collapse fragile tunnel walls, drown eggs and larvae, and worst of all, put the colony's queen in danger. And since the queen is the only ant laying eggs, her safety is quite literally the survival of everyone. So ants don't wait for the storm to arrive. Their antennae are extraordinarily sensitive instruments, capable of detecting shifts in humidity and tiny changes in air pressure long before a human would notice the sky beginning to change. Some colonies even respond by making their mound taller and steeper in the hours before a storm, building it up like a small levee, engineered specifically to shed water away from the tunnels below. And if the flood comes anyway, despite every defense, certain species have one final astonishing trick. Fire ants, for example, will link their legs and jaws together, weaving their own bodies into a single floating raft, with the queen and the young carefully cushioned safe in the middle layers. Trapped air beneath their waxy exoskeletons keeps the whole structure afloat. These living rafts have been documented surviving on floodwater for days, sometimes even weeks, drifting until they finally reach solid ground, at which point the raft simply peels apart and the colony starts digging all over again. So that ring of ants circling tightly and urgently around a hole, packing debris into the entrance, it might genuinely be a storm warning, written not in a forecast, but in the frantic, coordinated motion of a colony racing to save its queen. And then there's a fourth reason, the strangest one, the one scientists still don't fully understand. In parts of Germany, red wood ants build their mounds in an oddly specific place, directly along active geological fault lines, the very cracks in the Earth's crust where earthquakes are most likely to occur.
For years, researchers wondered whether this apparent bad judgment might actually be revealing something remarkable. So a team set up cameras and monitored several ant mounds continuously, 24 hours a day, for 3 full years. Under normal conditions, the ants followed a rhythm almost identical to our own, active and busy through the day, resting quietly inside the mound once night fell. But before an earthquake struck, even a relatively small one, that rhythm broke completely. The colonies stayed awake all night. Every ant remained outside the mound, fully exposed to predators in the dark, in a way researchers had never observed under any other circumstance. And strangely, this unusual behavior didn't return to normal the moment the earthquake happened. It lingered for roughly another full day afterward, before the colony finally settled back into its familiar pattern. Nobody knows with total certainty exactly what the ants are sensing. One leading theory suggests they may be detecting subtle shifts in the Earth's magnetic field in the hours before a quake. Another suggests they're picking up changes in underground gas emissions, carbon dioxide seeping upward through rock as pressure builds far below the surface. It's worth being honest here. This remains an active and still somewhat debated area of research. No scientist is claiming ants can replace a seismograph. But the pattern, recorded over years of careful observation, is difficult to dismiss entirely. It's a humbling thought, really. A creature with a brain smaller than a grain of rice, going about its ordinary business, circling a hole in the dirt, may, in certain rare and specific moments, be quietly sensing something about the planet itself that we can't feel at all. So the next time you happen to notice a ring of ants circling a hole, pause for a moment before you walk on. It might be a scent trail, folded in on itself, spinning a doomed and beautiful loop until something breaks the chain. It might be the opening act of an entirely new colony, wings catching the last light of a summer evening before a single flight that will define the rest of one queen's very long life. It might be a storm warning, a small and urgent act of engineering built to protect a queen no bigger than your fingernail. Or just possibly, on the rarest of days, it might be something we still don't fully understand at all, a whisper of the earth itself, felt first by the smallest creatures beneath our feet. 4 different reasons. One small circle in the dirt. And underneath it all, the same quiet truth that some of the most complex, coordinated behavior on this entire planet doesn't come from a single powerful brain. It comes from thousands of tiny ones, each one following a simple rule, each one trusting the ant beside it, building something none of them could ever build alone. If this helped you drift off tonight, or simply left you looking at your backyard a little differently, feel free to leave it playing. Subscribe for more calm, deep dives into the hidden world around us. Good night. Sleep well. And I'll see you in the next Sleepy Science.